everyone. Welcome to Introduction to Python. My name is Margaret, and I will be sharing with you the program language of Python. Python is a powerful, easy-to-use programming language that is ideal for scripting and quick platform development. It has effective data structures, a straightforward object-oriented approach, elegant syntax, and dynamic typing. Technology is a significant aspect of our world nowadays, so learning how to code prepares learners with critical professional skills for the future. Furthermore, building programs develop learners' creative and critical thinking skills. In this respect, Python's popularity and adaptability make it especially useful. Here are some of the schools that use Python in their school curriculum. Python is a free open source software allowing distribution, code reading, and modifications that run on GNU/Linux, Windows, Mac, and notebooks. The versatility of the Python language means developers use it on several platforms such as Jupyter Notebook and Google Colab. In this presentation, we will focus on Jupyter Notebook as there are many Intel SFI starter packs of which Python runs on Jupyter Notebook. Jupyter was created for use with notebooks, so you can easily use this on your Chromebook or other notebooks. If you're using it for the first time, we suggest installing Anaconda at www.anaconda.com/download, which includes Python, Jupyter Notebooks, and other data science packages, and is easy to install. To write and execute Python commands on Jupyter Notebook interface, you can pick up from this guide. LearnPython.org offers some advantages such as interactive learning, structured lessons, and free access. When using Python, you are communicating with your computer. The computer needs defined input data to process. This data can be categorized as string, integer, and float variables. To determine the data for your computer, you can use the equal symbol for the input function. Creating advanced Python programs require more than just utilizing built-in functions. Leveraging external Python files containing code, known as modules, allow access to additional functions and capabilities, enabling the development of more sophisticated programs. You can also bring out specific messages to the screen or other standard output devices using the print function, printing strings either from strings or other objects before being shown on screen. Once you understand the basic functions, you can create a simple game for yourself. Once you have grasped these basic commands, you can watch this video to get an overview of Jupyter Notebook's features. As mentioned earlier, there are many Intel SFI starter packs of which Python runs on Jupyter Notebooks. One of these starter packs is Plastic, Plastic Everywhere. The instructional objectives of this starter pack are to understand the problem of microplastics and possible solutions, as well as use Python and Jupyter Notebook to create a computer vision tool that can count the number of objects in an image taken from geographical sampling. Another starter pack would be Binford's Law. The instructional objectives of this starter pack are to determine the data sets of where Binford's Law apply and to apply Binford's Law to fraud detection. There are worksheets for learners to have hands-on practice with Python and Jupyter Notebook. One activity in the worksheet would require learners to upload files and images onto the library of Jupyter Notebook in order to create and test out a Python script. Binford's Law has a similar workflow in their worksheet. To create command prompts as scripted in the Plastic Plastic Everywhere worksheet, upload the necessary images to the library. With the uploaded images in the library, the instruction for learners is to key command script in order for an image to appear as output. Same for Binford's Law. To create command prompts as scripted in the worksheet, upload the necessary images to the library. With the data files uploaded in the library, the instruction is for the learners to generate Binford's Law bar graph showing the frequency of numbers and compare to see the accuracy of the graph. Writing code is a process that requires a lot of attention to detail. Small mistakes can cause your code to break and create errors when running the program, so it's important to pay close attention. There are three main types of errors in Python. Compile time errors. These are errors that occur when you ask Python to run the application. Runtime errors. These occur after you have compiled the code and the program is running. Syntax errors. These happen when you have entered a code wrongly. Python will usually display the error type so you can easily look up the error code. It is important to be able to have a place to look this up, so the Jupyter Community Forum is a great place to look and learn how to fix it. Thank you for listening, and please reach out if you have any additional questions.